Welcome back to Porter Podcast.
You know you're totally looking the other way when you started that.
You told me to look up there.
Yeah, to see when to do it.
Did it get it?
Yeah,
Okay.
I'm sure it did. Just like it's going to go up and down in volume. All right, so we've talked about ionic compound characteristics. How would you describe an ionic compound? How do you classify an ionic compound? No, ionic. Go back to ionic. How would you classify it? Okay, so metal and non-metal. What else did you say? Cation and an anion. Good. And what about the electrons? What are they doing in an ionic bond? Not quite. Not being shared, they are being transferred. So electrons are transferred. And this is all describing ionics. When we jump over to covalence, we see some key differences. One, we're dealing with two nonmetals that are bound together. Electrons are now shared. We'll get into this electronegativity in a second. But if you guys are looking at the characteristic of electrons, so for ionics, if we had sodium, for example, and fluorine, you guys spent some time drawing these electrons being transferred, like so. So you eventually get Na plus and F minus for an ionic compound to be formed of NaF, sodium fluoride. So that is an ionic compound because it's a metal, non-metal, it's a cation and an anion, a positive being attracted to a negative, a transfer of electrons. When we talk about covalence, chlorine has 7 valence electrons. If I want to combine it with another chlorine that has 7 valence electrons, we're not going to give away or gain electrons, but instead, you're going to see electrons being shared. So if those two electrons are being shared, how many electrons does each chlorine think it has?
8.
Yeah, it thinks it has 8 valence electrons. Both chlorines are now happy. Those shared electrons are describing a covalent bond. Now, when we talk about bonds themselves, we can really get down into the nitty-gritty by looking at the electronegativity values for your elements. If one element isn't strong enough or have a high enough electronegativity to pull the electrons all the way over to itself, and instead you have electrons that are just kind of sitting in the middle, like these being shared, that's when you have a covalent compound. When you have electronegativities that have really large differences, such as a metal and a nonmetal, so you guys have seen this on test, metals have high or low electronegativities. Low electronegativities. Nonmetals have high electronegativities. When you have a big difference in the electronegativity values, that means electrons can be pulled all the way towards one of the elements. So in this case, the nonmetals are able to pull all the electrons or those valence electrons towards itself, while the metals kind of readily give up those electrons, and thus we have a cation and an anion formed. When we have electronegativities that are closer in value, So in this case, we have Cl and Cl. They have the exact same electronegativity. The difference between the two in electronegativities is 0. As a result, neither one necessarily pulls the electrons to itself. Instead, the electrons just kind of sit in the middle and are shared. So that's the depth of this. We're going to kind of hang on the surface and focus purely on, we have two nonmetals that share electrons.